Okay, so now we're going to discuss lift chart or cumulative lift chart. In SAS Enterprise Minor. And here we're going to be comparing the cumulative number of events. Okay, as you go down from, you've already arranged the cases in the descending order of propensity. So now you look at the cumulative events, actual events, okay, as opposed to naive model events. Okay. So we have to generate another table like this first, and let's see. So we go back here, okay, and these three columns, we do a pivot table. And let's put the pivot table right there. Okay. Now case number. All right. So now you don't have to use decile-wise chart. You can be, the SAS Enterprise Minor divides the classes into 20 equal classes as opposed to 10. Okay. But let's keep it at 10 for now. But you don't have to use 10. It can be anything, like 15, 20, 25. But since we have a very small data set, let's keep it at 10. Okay. Now what we need here are a couple of things. One is we want the actual class, okay, like in previous case. But you want this to be the sum. So you want how many events are actually there in each group. Okay. So in the first group there are 3, second group there are 2, and so on. Okay. So how many actual classes there are? We need one. We need that. Okay. So let's call that events. Okay. How many events are there in each group? Then we also need how many cases there are, because sometimes because these classes are not full whole numbers, okay, there may be a problem. So number of observations or number of cases. So let's put the case number here, and that will be count of cases. All right. So how many cases there are? So this is just cases. So these are the 2 columns that we need from the pivot table. So how many events there are in each row, and how many cases there are. So now we can compute a couple of things. So let's see, cumulative events. So here are the events in each class. So we have T10 and then the previous cumulative plus T11, and we copy that down, and that gives you the cumulative events. Okay. So as you go down, how many events are being captured as you go down from the top to the bottom. Okay. So this is the cumulative number of events for each row. Now the naive baseline number of events, Okay, so that would be the baseline that we want to compare. Baseline random let's call it events or baseline events, and that would be random assignment. So what this means is that we're going to randomly assign we have 12 events, and we're going to randomly assign those 12 events to each of these classes. So now we have 10 of these, so this will be just simply T20 divided by 10. Okay, so you're going to have 1.2 events randomly assigned, so that would be your baseline. And these are the cumulative, so this is cumulative, so we need to do a cumulative baseline. Cumulative baseline events will be, first one is just that, and then you do the cumulative. Okay? All right. So, after having sorted the list from largest to the smallest propensity, as we go down, the number of events that we capture by the classifier are these. So as you go down for the first 10%, you would have captured 3 actuals, whereas in the random assignment, you would have captured 1.2. As you go down to 20%, you would have captured 5 of them in the random class, in the DM classifier. You would have captured only 2.4 in the random. So as you go down to the bottom, at the end, in either case, you would have captured all of them, whether it is DM or naive. Okay? So what we need to do now here is to divide one by the other. So the cumulative event of the DM divided by the cumulative event of baseline. So we can call it DM here, DM cumulative event. So remember that this is what we call cumulative lift. So we plot that as a line graph, and what you get is the cumulative lift, and it always, so each point is a comparison between the data mining classifier, okay, how many actual classes are captured divided by the random. Okay. And the random would be, you take the total the total cases, you multiply the total number of cases by the percentage of the event. Okay, so that's what will give you the baseline. So this is cumulative lift for riding over SAS EM. So this is your lift, and this is your cases, percentage of cases. So you can hear, what normally you will see in the x-axis is percentage of cases. So let's do that. percentage of cases. That's your x-axis. Okay. So there are totally 24 cases. Okay. And those are for each row. These are the number of cases that actually are in each row. So if you divide U10 by U20, U20 being absolute reference, that will give you the percentage of cases. Okay. So that's your x-axis. Design. So if you are using a scatter plot, then you will be able to do this within each line. But in a line graph, you do it this way. Sorry, you need to find cumulative. Sorry, we need to copy that here. So it should. Oops. We need cumulative number of cases, because at the end you should have 100%. So you will have that. Okay. And that should be your x-axis, not percentage of cases. It is the I made a mistake. So I need to go to design, select data, and this should be the cumulative. Okay. So as you go from left to right, at the end you get all the data, 100% of the data, and at that point your lift is going to be 1, because you would have captured all the positive events in either case, both DM as well as the naive. So the ratio will be 1. Okay. So the higher the point is in this area, so the better it is. Okay. So the ideal case would be like a sharp curve like this, okay, going dramatically down and then flat like that. Okay. Starting from really large value for lift. The top, so here the top 12.5%, you have a lift of 2.5. You are able to detect the actual rates at a 2.5 times better than the naive, and then here it is almost 2%, twice as much, and then so on. Okay, so this is the lift chart that you will see in SAS.